So I'm definitely not yet as well paid as Shohei Ohtani, but we'll try to figure that out later. So I'm going to talk about building practical AI agents for software development. And the reason why I want to do this is, let's say I gave you some tools. I gave you the ability to use a web browser. I gave you the ability to edit text or edit files on your computer or something like this. And I gave you the ability to run programs. What sorts of things do you think you could do if you had the ability to do all of those things? I'd say I could do maybe 98% of my job, right? And so this is a pretty powerful tool set, and it's not a huge tool set. It's just, a number of tools that we can use in very powerful ways. And if we're able to give AI agents the ability to do this sort of thing, then we could really, make wonderful things happen. Just to give a demo, I try to give a different demo every time I do this sorts of things. So I've never done this one before. So if it doesn't work, you'll know, at least it was real. But I have find the financial reports for the city of Pittsburgh from this site and create a website that visualizes them in an interactive and engaging ways. So I can put them into to our agent here. And it will go out and do this. It started by browsing the web, so we can see it went to the Pittsburgh website over here. It's now downloading all of these, so we can see in the workspace it's going to be downloading the files into the workspace. And then it will be, we can see it downloaded the files into the Pittsburgh financial data thing here. And then it will continue working for a bit, and it will probably spin up a website to do this analysis for us. I'm not going to make you wait and watch the agent because I only have 25 minutes to talk to you, so I'm going to continue, but hopefully when we go back, we'll be able to see an analysis there. So I already gave a little bit of profile, so I'll skip through this pretty quickly. I'm a professor at CMU. I'm chief scientist at All Hands AI, which is a startup that we formed, and I'm maintainer of OpenHands. So OpenHands is a open source toolkit for software development. It formed about almost a year and a month ago, and around the idea that software developers, especially after the launch of other toolkits like Devin came out, we saw that agents were going to be the future of software development, and we wanted to create them in a way where everybody could participate, basically. So, if software developers are going to have their jobs greatly changed by AI, we believe pretty strongly that software developers, including us and including other people, would want to participate in that process. About 3 months later, one of the main contributors here, Robert, who's the CEO of the company now, messaged me on Slack and basically said, I quit my job. And I was like, oh, okay. And he basically said, I believe in this. I want to be working on this. I'm going to try to form a company around it. Are you with me or are you not with me? And I said, okay, fine, I'm with you. And we decided to do that. Another thing I'd like to point out is I myself am a software developer. So this is my activity on GitHub. You can see that I work on something almost every day. Actually, my number of contributions doubled from the time that I started before I started working with agents to when I work with agents. So it's not like I don't write software anymore. It's more that I just write software faster. I write software for more things that I wouldn't have been able to do normally. And it's, greatly accelerating our process. Because this is about agents, I've learned a lot in building practical agents that, I use every day. And I worry about a lot of different things. I picked out 9 things to talk about just to give an idea of some of the challenges in the field. And the first thing that I worry about is the way that we as people interact with AI agents or the agent-computer interface. And, I apologize. How do agents interact with our computers? The other part is part 2. So how can we provide agents with tools to do the job? The way that we decided to provide agents with tools to do the job is instead of having a lot of complex tools that we designed specifically for computers, we just let them write programs. And the reason why we just let them write programs is programs are, typically the way that humans communicate with computers. So if we allow the agents to write computer programs, that allows them to do most of the things that humans can do with computers. And, human programmers can do great things with computers. So this is a very kind of natural interface to allow humans to communicate with computers. If we look at specifically the tools that the agent will need to be able to access in order to make this happen, we provided the three things that I mentioned at the very beginning of my presentation. We provide them with the ability to execute programs using, for example, running things on the Unix command line or writing Python programs. We also give them ability to edit files and browse parts of files. And so this allows them to read programs, change programs, and other things like this. And we allow them to do web browsing. So we can allow them to go to URLs, click, and type. There's also other people like OpenAI's computer use agent that allow you to click on individual parts of the screen, but we've decided not to do that because it's a little bit harder for agents to get right. So we just allow them to select the elements they want to interact with. The important thing here is there's a lot of other things that we would want agents to do. For example, we might want them to interact with code repositories on GitHub or other things like this. But all of these things can be done by writing a Python program or writing a Bash program or other things like this. So very early in our project, we moved away from trying to give the agent lots of specialized tools and more towards just allowing it to use existing software libraries to interact in the way it wants to. The second thing I worry about is the human-agent interface. And this is actually really a really interesting problem, really hard to get right. We have some guiding principles, which are that we want to present enough information to the user to allow them to explore more, and also to go where the user is, but to a point. And what I mean by this is we have a chat UI for interaction, which is what I just showed you before. We also have a GitHub plugin that allows you to tag and solve issues. So you can write @OpenHands on your GitHub, and it will go in and start a session in the interface. And you can either forget about it and come back later, or you can actually click in and see what the agent is doing and other things like this. We also have an integration with Slack, which was done together with another startup here at CMU. And we also have an API for launching jobs programmatically. So if a programmer wants to set off 10 jobs and get 10 agents working on things at the same time we do this. I also have ideas for other crazier things, like what if you could just talk to the agent and it would do things for you and other things like this. But these are the ones we have implemented at the moment. And the best one, depends on the use case. Maybe I will go back and check the agent's work. So, oops. So yeah, here it made the financial dashboard for the city of Pittsburgh in the past 5 minutes or something like this, which is I think pretty impressive. Telling you property taxes, all of this stuff. If I were actually to care about this a lot, I would definitely go in and check to make sure that all of this data was correct and not hallucinated from the language model. But, I think it's a good template. Also, I think I would stop this bar chart or this line chart from continually expanding forever. But, It's a start, shall we say. But anyway, yeah, as I mentioned, we have things like viewing the changed code, looking at the workspace, looking at a terminal, a Jupyter notebook, the app in the browser, and other things like that. Cool. So This is actually, I think, a pretty big, key to how people are going to interact with agents going forward. And like one big issue that we've encountered is now it's very, very cheap to generate code, but it's a lot harder to go in and confirm that it's actually correct. And so I think a lot of the innovation that we and other people are probably going to do over the next, short amount of time is going to be how can we allow people to confirm that the programs are working properly and other things like this. And we have some technical innovations that I'll talk about in a bit to do that. Another thing I think about is choosing a language model. So like everybody has heard about large language models, and an agentic language model must have good instruction following ability, tool use and coding ability, especially if you're writing software. It must understand its environment. So if I wanted to ask the language model to go in and look at the web page and realize that the bar chart or the line chart was like continuously expanding and fix that, it would need to be able to understand web page screenshots. And that's not something you can take for granted. And some language models are better at that than others. It also has to have good error awareness and correction ability. So like, let's say it made a mistake. Could it identify that mistake and go in and fix it? So one failure case of language models is that language models will get stuck in loops and do the same thing over and over and over again because they can't find an alternative strategy when they fail. And some language models are better than that. Another thing is reasonable cost. So, actually, when you're doing an agent, you're querying a language model over and over again every time the agent takes a step, and that's pretty expensive. There's some implementation level details that you can use to fix that. Like there's something called prompt caching that allows you to cache all of the agent history and retrieve it efficiently. But separately from that, just how can we make smaller language models that are nonetheless competent to do well at these tasks? On our benchmarks, we do very extensive benchmarking. We mostly focus on a benchmark called SWE-bench, which I think maybe a lot of people have heard of for software engineering. But we're also benchmarking on a lot of other benchmarks as well. But anyway, here on SWE-bench, I've just given like 5 representative ones and then our strongest system on the right. So Claude Sonnet is the strongest one with 60.6% accuracy. O4 Mini is at about 56% accuracy from OpenAI. Gemini from Google is at about 48. DeepSeek is about 38. And we've actually trained a small model that you can run on a single GPU that is competitive with DeepSeek. And we're continuing training models and stuff like this so we can use them as alternatives to the more expensive counterparts there. I'll talk about the re-ranking part in a second. Another thing that models need to be able to do is planning. And planning, when you build agentic systems, there's a couple different ways you can do this. The first way you can do this is you can say, I'm going to build an agentic workflow, and this workflow will be followed by the agent, and it needs to go through it step by step. And I think that will work if you're doing a very specific type of thing over and over and over again. But in software development, there's so many different things that people do. People do writing code, they do debugging, they work on Python, they work on JavaScript, they work on a bunch of different repositories. And we found that fixed planning workflows just have not worked for the variety of tasks that we want people to do. And so instead, we're just letting language models generate plans on the fly. And language models like Claude are reasonably good at doing this. Another thing is explicit structure versus implicit structure. So you can have a language model like dispatch to have an agent dispatch to another agent. So in the early days of our software project, we had a coding agent that would dispatch to a browser agent, and then the browser agent would go browse, and then it would report back. But we've recently switched back to just having a single agent that can kind of do a lot of different things, but structuring its behavior around prompts, because that makes it more flexible and able to deal with like contingencies that weren't seen before. And I actually have a blog post about this. It's called Don't Sleep on Single Agent Systems. Another thing that we've been looking at is specifying common workflows. So software engineers do many, many different things, but a lot of the things are somewhat repetitive. And you can get them right, or you can get them wrong. And one way to make sure that they get them right more often is by providing detailed directions about how to do these subtasks. And we have an idea called micro agents in our toolkit, where basically people can create a short instruction about how to solve a particular subtask that are created by users. But on the research side here at CMU, we are also doing research on how to kind of induce these workflows automatically. So we have something called agent workflow memory, where basically what we do is we take successful tasks, tasks that were judged as successful, we split them into workflows, and we add these workflows back into the memory of the agent so it can reuse them again. And we've demonstrated on web navigation tasks that this can lead to a 20% increase in accuracy over just, a few examples. Another thing that I worry about is exploration. So how can agents learn more about their environment before acting? And in coding workflows, there's a bunch of different ways to do this. The one popular way of doing this is to basically provide the agent with the full structure of the repository that it is dealing with, and have the agent gradually drill down into the place where it should actually be modifying to make a fix or something like this. So within code, this is actually somewhat easy because you can kind of traverse the whole environment and understand it. For web navigation tasks, it's a lot harder. You need to do things like click through a website and do, exploration of the website, understand the structure of the website so you can use it well. It's kind of like once you've used Amazon over and over again, you get much better at using Amazon in the future. And so we're also doing some research work in this direction to figure out the best way to do this. So another thing is search. So the typical way of using an agent is you just go on a linear path and you have the agent take step by step by step by step, and it ends up, either finishing the task or not finishing the task. But if you want to get really high accuracy, like if you want to get on the top of the SWE-bench leaderboard or something like this, actually this is not sufficient because agents will go down rabbit holes and they'll make mistakes and not be able to get out of the mistakes that they made. So another thing that we just demonstrated, we released a blog last week, is you can explore multiple paths and pick the best one with a critic model. And the critic model, basically what it does is it looks at, 5 different paths sampled by an agent, and it says, okay, this one looks like the most promising one. We'll select this one and use that as the actual one we show to a user. And we demonstrated that we could take this, and a single run through the SWE-bench verified dataset gives us 60.6% accuracy. But with 5 runs in this critic model, we got a 66.4% accuracy. And this is the highest score on the leaderboard. So this is a pretty effective approach. A final thing is evaluation. And because this is a more general, audience about agents, I want to share a really evaluation benchmark that I really like. But first, I want to talk about kind of our more vanilla evaluation that we do when we're doing like our standard evaluation for agents. And one thing about evaluation is that it can be pretty expensive. So to do a single run of SWE-bench with our best performing models, it can be like $500 to $800 for a single thing. And so if we want to do iteration over and over and over again, that takes time, that takes money. Researchers are a little bit worried about it. And so we also have alternatives. So there's like some kind of very simple web browsing benchmarks like Mini World of Bits or the 8er code editing benchmark for codes. So you can use kind of simpler benchmarks. You can also subsample existing benchmarks. For high realism evaluation, we use Web Arena. For web, which is something that we use here, but it's we created here, but it's a pretty standard benchmark for web navigation now. And also SWE-bench for code. Also, we're looking into more diverse evaluation. There's a whole bunch of different benchmarks for software engineering tasks that we are creating kind of a more unified benchmark. But I want to introduce this particular benchmark that we created, late last year. It's called the Agent Company. And the reason why I wanted to show this is because this is a benchmark where we essentially set up a fake software company. And the fake software company has its own chat app called Rocket Chat. It has its own Google Drive style thing called OwnCloud. It has a source code repository, GitLab, and a task management system Plane. And all of these are clones of the actual software that people use in real businesses. Not clones, but they're alternatives. So Rocket Chat is like Slack. OwnCloud is like, Google Workspace. GitLab is like GitHub, and Plane is like Jira or Linear or something like this. And so we created a whole bunch of tasks, not only for software developers, which we did do, like preparing a code release, but also for administrators who were arranging meeting rooms, data scientists who were analyzing spreadsheets, HR who were doing resume screening, PMs doing team sprint planning, and finance who were reimbursing travel bills. And we set up 175 of these tasks, each one that has intermediate checkpoints. So you can go in and check if you got part of the task done instead of the entire task done. And we found that the best language models at the time, Claude 3.5 Sonnet, were able to completely finish 24% of the tasks and get a partial match score of about 34%. And so that doesn't mean that 24% of the tasks that people do in an everyday workspace can be automated. Actually, what it means is those 24% were like the simpler ones, and then there's a lot, harder ones over here. But I think this is the most realistic evaluation of kind of like very general agents in a kind of standard workplace setting. And it actually just got featured in Business Insider 2 days ago or something like that, saying AI won't take your job yet. So I guess that's good news. The final thing is safety. So safety is really important when we're deploying these, and we take a three-pronged approach to safety. One way is through sandboxing, and what this means is we only run agents inside a sandbox where they can't break things outside of that sandbox. Everything's run in a Docker container, if you're familiar with that. We also have credentialing, so agents are only given credentials to do the things that they should be able to do. So we use the principle of least privilege, only give the agents the ability to, touch things that they should be able to touch. And also auditing. So we have a post hoc auditor that can view each of the agents' moves and decide whether that's something that should be executable or not. So yeah, that's all I have for today. My conclusion is right now we have a huge effort in, so these are some of the things that are next. There's been a huge effort in training language models to be good agents. I expect capabilities to go up and price to go down in 2025. Benchmarking will continue to improve. We've seen a ton of really nice agent benchmarks coming out, but will still be difficult to meet realism. I think agents will move into native interfaces and software will become less visible. And what I mean by this is we're going to be spending less of our time in our IDEs and more of our time, creating issues, doing project planning, talking to each other, deciding what features to be using. Because the agents are going to be, writing a lot of the code. And so we can go in and verify the code and focus more on the higher level things. Also, progress is already very fast, but I expect it to get faster because we're using agents to build agents. OpenHands is the biggest contributor to our OpenHands repo right now, and that's only going to get better as agents get better. So I think we're going to continue to see this grow by leaps and bounds. Yeah, and if you want to try it out, I have the link there, and anybody can try it for $50 of free credits. So, yeah. Cool, thank you.